Sir, can you start, sir?
Yeah, sure. I can start. Yeah. Everyone, please open your Spider on Anaconda. We will continue with the yesterday's program. A little part is remained for us to evaluate the machine learning algorithms. Okay. Let us do that now. Wait a second. I'll share my screen.
Sir, good morning, sir.
Good morning, ma'am.
Sir, we can start now.
Okay. Yeah. I hope you guys practice the yesterday's program. Any other sample which is similar to that? I already shared the code with you. I'll share it today as well. I'll share the code today as well. So if anyone missed it yesterday, you can get it today itself. Okay. So just a quick revision of everything. So yesterday we were getting this complete. We got all the libraries that we would need, and from those libraries, we imported multiple modules that are needed for machine learning evaluation problem. Okay, so this use case is basically a very important generic template for performing machine learning algorithm evaluation. Okay, the reason why we had to discuss this is because why this is the first problem that we had to discuss is because anytime whenever you build any kind of machine learning model, first you need to evaluate for for a particular data. Okay, for a particular amount of data, you need to understand which algorithm would be the best suited one to get more precise output. Okay, that those evaluations needed to be done for sure. Only then, once you found the good trainer, which trainer you want to use, or which one is the most efficient one, based on that you will implement the algorithm. Okay, so this evaluation problem is pretty important. So for every machine learning or deep learning problems, we need to evaluate the algorithms like this. Okay, so I got the dataset dot shape in group by. uh, so let's take this out. Yeah, we implemented all these pandas functions. These are from the pandas library, and then we used a way to split the information into two parts. Actually, yesterday we stopped at the place where we tried to split the complete information. Okay, so array is the dataset values x and y, x validation, y validation, and all these. So the splitting is done. So what we need to do is, once the splitting is done, we need to take this information and take all the algorithms that we have, Okay, take the information, the training information, take all the algorithms that are to be evaluated, and then evaluate one algorithm after another. Okay, so we are going to use a array approach for the same. Okay, we'll be implementing the code in an array. Let me first write the code. You guys can write it somewhere. My spider is crashing somehow. Let's try to open it again. Okay, after yesterday's code, please write this problem. Please write whatever I am executing here. So, if you observe, yesterday how many models or algorithms we imported? I think there are nearly three, which we nearly six. Sorry, six algorithms we imported. Okay, one after the other. So now we will take these algorithms one by one and we will evaluate them in such a way that the results would be displayed one after the other. So, how to implement that? Okay, let us try to understand that. 1 minute, guys. Spider is crashing multiple times. Okay, hope you are able to see my screen. So, data splitting is done and the size is evaluated. Let me save this program. I think I was not saving it. Let me save it somewhere. Iris. I'm naming this file as irisevaluation.py. You can give any file name, that is up to you. So I grouped by the class and everything, and then let me put the data for the splitting. Now see, so here is the main, the heart of the program comes into picture. So how, the question is, how do we evaluate multiple machine learning algorithms using Python? You know, the important thing here is we'll do that in a single shot, means at once, not one by one, because we'll optimize the code in such a way that we'll be doing it all at once. Okay. So here the algorithms that we imported are, if you go to the previous code that we wrote, from logistic regression is one, decision classifier. These are the multiple algorithms that are there. These concepts you can learn. You can learn separately. I think these must be included in your syllabus, or I'll give you a manual to learn about these algorithms. If I just tell you the theory of these algorithms, then it would take nearly 6 hours of concept only. As we are focusing on the hands-on session, I'll tell you how to implement them. Once you get these, how exactly you need to implement these classifiers. Okay, so these are, I'll send you one documentation anyway to learn more about these algorithms. I think yesterday I already shown you the scikit-learn's official website where we saw regression classification and all those. So I'll send you the information. So logistic regression, decision tree, these are nearly six, and we need to evaluate one by one. So what the approach that I'm going to do here is I'll be using a array approach to do this. So what I'm trying to implement is I will take, so see, these are all algorithms, right? So what I will implement is I'll take algos, a short form of algorithms, is equal to, so what is this? You can call it as an array or a list, right? I just took a empty array, and to that, what happens if I write algos.append means append is a function. Uh, it is an array function or a list function which will take the element and add it in the at the end of the array. Okay, for those who don't know, so I'll tell you the syntax here. Whatever the element that you want to add, you need to write it in the brackets. You need to send it as a function element. And to this function element, what I'm trying to do is to this array, uh, I will add a tuple. Okay, see, I'll show you the declarations here. Try to observe here. This is just a sample code. If a is equal to something which is defined in the square brackets, let's say 1 comma 2 comma 3, that is an array. Okay, b is equal to, if I write brackets 1 comma 2 comma 3, you can call this as an array, but this declaration is called a tuple. This is one kind of data type that we have in Python, right? So here what I am doing is to this function, to this append function, so this is the append function. Okay, I am taking another tuple inside it, open brackets, string value lr means logistic regression. Okay, logistic regression comma, that is the first element, and the second element here is, see, in a tuple you can actually write a function as an element. Okay, I'm taking the function as one of the element in the tuple, and the function here is the first algorithm, that is logistic regression. So this is how you basically import the function, the logistic regression. Okay, so the next algorithm that we have here is decision tree classifier. So also append, so what I'm doing is I'm making an array of algorithms by appending all the algorithms that we want to evaluate. Algos.append LDA, linear discriminant analysis, and I would write linear discriminant analysis. This is a function. So likewise, you need to import 6 algorithms that we have. So let's write the code for them. So what will happen? What will be the, at the end, what will be the exact data type of algos array? It is nothing but a list of tuples. Okay, it is a list of tuples. So LDA is 1, KNN is 1, neighbors classifier. This is one type of classifier. Likewise, I need to get decision tree classifier, Gaussian as well. Let me give you the
Uh,
code.
Evan, sir,
Yes, sir.
if a few words about this logistic regression, linear discriminant analysis, k nearest neighbor, you
Yes,
can go
yes.
to a few words about this theoretical concept. What are the purpose can go to apply in this application? Can go to explain, sir. Next, we'll
Yeah,
move
yeah.
to our application. Okay, thank you, sir.
So here, yeah, that's what I was trying to say. Here we are doing algorithm analysis. We are not, see. I think that is what I was trying to say. Here we are going to evaluate these algorithms, but not implementing these algorithms. Okay. So I'll also tell you for which purpose we can use these algorithms once the evaluation is done. Because after evaluation, we will find out which one is more efficient algorithm, and then we will implement it. So these are the total 6 algorithms that we have, right? So please import all these, and next, okay, write the code. I'll give you some time. So once that is done, you can actually print the algos, print the algos array, and see what all values will be there inside this newly formed array here. Okay, so it should be, if I, let's see what happens if we run this. Okay, so this should be the output you must be able to see. Just check for the syntax errors if you have any. This is the whole thing. Okay, so next, for the evaluation part, we are going to implement looping here. Let's see how looping can be implemented to find out this. Okay, I hope everyone is getting this output. Let's remove this statement. So I'm going to make two more arrays here, which will carry the results of the operation. So see, the implementation, the architectural overview of this implementation is we'll evaluate one by one, and we take the output of the evaluation result of each and every um, each and every algorithm, and we'll store it in the results. And also I want to print the names of the algorithms that are getting evaluated. Okay, so now what we need to do is listen carefully. So to estimate the model accuracy, this concept is important. I'm going to tell you how you basically evaluate the algorithms functionally by using the functions directly here. There is one approach called, okay, stratified k-fold. Okay, so this is a generic approach for evaluating you can actually use this to evaluate your model accuracy. Okay, so the purpose of this is to estimate model accuracy. Okay, so here what is k we will discuss, and there is one value that we give to k actually. So let us say this is the data set that we have. Okay, the small block is the data set. So ideal, what do we have here? See, this is a training data set. Okay, because you already split the information into two parts, remember? So this is the second part, which is 80% of your data set. Okay, just to reiterate on what happened yesterday. Yesterday we discussed that you need to divide your algorithm into two different parts. Sorry, your data into two different parts. This is the training information, and let us say this is 80% of that information, and once you get this training information, we basically divide this into k folds or k parts. Okay, what is k here? So k is the number of parts you divide this data set. Okay, I'll tell you why we need to divide this. 8, 9, and 10. So internally, what happens is, so this is also called, this process is also called k-fold cross validation. So what does this cross validation mean? And how many folds do we have here? We have 10 folds in this. Okay. So instead of k, now I have 10-fold cross validation. So that is what we are implementing here. So what does this do exactly is, this is all your information of the flowers that we imported, right? So we took all the flowers, and we are just trying to import everything. So now what happens is, once it splits this information into internally, what happens is, when you find out the stratified k-fold value, it will take one fold at once. So this is one fold, right? This will take one fold at once in the first iteration. So how it happens here is, this is kind of a little confusing. Try to understand properly. If you have any questions, you can ask. In the first iteration, what happens is, it will take one fold here. And see, this is all training information only. And it will evaluate or check 9 folds. Means 9 folds will be used as training information. Okay. And one fold will be used to test how efficient is this training information is in these 9 folds. Okay. Means what? You are teaching the algorithm, you are trying to teach the algorithm by taking these 9 folds of information or 9 parts of information at once, finding the score or the validation score by taking one fold each. Means what? See, it is very simple to understand. In these 9 folds, let us say we are executing one simple example, that is Apple's example. Okay, in this 9 folds I have values like 150 grams, so weight is 150 grams, color intensity of red is 80%. Okay, and 140 grams, color intensity is 75%. I'm taking information of various different apples here, and I have 155 grams and the color intensity is 90% of red. Okay, so now this is the 9-fold information that I have. For example, in the test information, and also let us say that the whole 10-fold information here is, this is, if you take 10-fold, means the complete information. I have 150, 140, 155 and 160. Okay, so now what will happen is, this is the 9-fold value and one fold is taken as test information, that is 160, and it will verify how is this machine learning algorithm identifying this 160 as, either it is identifying it as apple or not. It will verify that. If it is showing apple, and in the next iteration, what will happen is, this is the first fold. Okay, in the first iteration it took first fold. In the second iteration, what will happen is, it will take second fold and test it against all the other folds, means 1 3 4 5 6 7 8 9 10. In the next iteration, it will take 3 as test information and test it in front of 1 2 4 5 6 7 8 9 10. Next 4, next 5, next 6. So likewise, you divided this information into 10 folds and you verify, you're basically, what you're doing here, you're training the machine learning model with the same information and you're testing the information, testing the model with a similar information. Okay, and you will evaluate a score out of which how efficient this is working. Then it will be called as 10-fold cross value score. The name itself, cross value, means you cross check everything, how this model is working, how the results are coming out. Okay, so how to implement this programmatically is what we will see now. If you take all these names, now what I'm going to do is, I'm going to implement one simple for loop here. For I'm taking two random variables, okay, name and let's take like algo. In algos, I'm taking two values. Why? Because if you observe the structure of each and every algorithm here, it is carrying two values. One is the name of the algorithm, that is LR, and the algorithmic function itself, that is logistic regression. Okay, I'm taking one at once, and then what I'll do is I'll find the k-fold value. K-fold is equal to find it, we already imported one stratified k-fold function here from the scikit-learn. Okay, so we will take the stratified k-fold. So this is the function that we are going to implement. I'll tell you how to customize this function later. Once that k-fold value is found out, you need to find something called CV results. CV results is a variable that I'm assuming. CV means cross value score. So here you first configure. First of all, you need to tell, see the same implementation we are trying to do here as well. Just a second. If you see, first of all, you need to tell to how many folds you're dividing this information. And ultimately you need to, this functionality, this iterations and all will happen inside the function. Okay, you don't need to write the code for it. It will happen inside a function called this one. Splitting will be done by using the function stratified k-fold. This will do the splitting functionality. Now this is the evaluation functionality, means how accurate the cross value score is, or what is the value of the cross cross value here. So there is a function called cross underscore value underscore score. Okay, so this is step number one, and this is step number two. So now how to do this is, for CV results, I'm going to use cross val score. Okay. And see, results is the array that I already that I already declared here, right? I didn't initialize it. So what I'm going to do is, it is an array, so I can use this function append. And what I'm trying to append here is to all the results that are getting evaluated for each and every algorithm should get and stored in the results. So I'm going to save CV results here. And next, for the names, I'm appending the name of the name is nothing but these string values: LR, LDA, KNN, CART, NB, and SPM. Okay, so what are you trying to do here is, you're trying to obtain the cross value score. Okay, once this k-fold is implemented on each and every algorithm, okay, what will happen? How would be the results? So step number one is to divide this into 10 different splits or 10 different folds. So I would write n underscore splits is equal to 10, and the random state here, random state, I told you, just used to mix the information, and you can also shuffle, you can also use one other parameter here, which is shuffle. It will shuffle the, because see what will happen is whenever you are trying to divide this information, if you shuffle it really well, this 80% information, 80% of the training information that you got, if you shuffle it well, it will be a mix of various different parameters or various different species of the flowers, right? So that's why keep shuffle as true. Even without shuffle also you can do, but if you're using shuffle, it would be more accurate. So I divided this into 10 different splits, that I implemented in line number 82. And then to obtain the cross value score, you first need to take the algorithm and pass it to this function. You need to take the algorithm, and next you need to take the next train information. So as I told you, you will obtain the results by using the training information only, right? So this is the training information. %80 that we divided. You may ask me, why are we using xtrain? Is because, see, here we stored the training information that we are obtaining in xtrain. That's why I took this xtrain, and also ytrain. Ytrain will consist of what? The labels of the information. Xtrain will consist of just the sepal length, sepal width, petal length, and petal width values. That's it. So I would write ytrain. Cross value method is k-fold. So cross value score will be given here because the k-fold value will be obtained here. And which kind of score that I want, I just need to find out the accuracy, how accurate these algorithms are. That is what I need to do. So I want to find out the scoring technique here is find out the accuracy of the model, how accurate it is. Okay. So stratified k-fold is basically used to find out the cross value score of multiple algorithms that you can have. So now I need to print the information. So the score will be obtained here as CV results. Okay. So what I'm going to do is print. First of all, I want to print the structure as name of the algorithm. What is the cross value scores, mean value, and standard deviation. Okay. So I will take string yes. Percentages represents, it is going to print a string value in that particular format. So after that string value, I will have a float point, and inside this bracket I'll have another float point. And what do these represent is S is nothing but the name of the, so this is a basic syntax of printing the values in a particular format. Name, so this percentage S represents name. Percentage F, the first percentage F is nothing but CV results dot mean, the mean of the CV results, the mean value, and also CV results dot STD means standard deviation. Okay, check whether this is correct or not. Okay. So now what will happen if you look at the functionality? In by line number 76, algos will be having the list of, or the array of the complete algorithms that we have. And next we have an array where we are going to store the results, and then names which will store the names of each and every algorithm that we are actually working on. Okay. So next, what we did was we took a loop. We tried to loop inside the array that we created. We took name and algo at once. Algo is one algorithm at once. So we took those values and we tried to find out. Every time I took a k-fold by doing the 10 number split here, and to this function cross value score, I'm sending the algorithm that I want to evaluate and training information, and also the score that I need, the accuracy score that I need. And once the results are obtained, I will be appending those results or adding those results in the array called results. And then line number 83, it will take all the names. And finally, I'm printing the, so now this print is inside this loop itself. So it will continuously print these values, right? So write this. I'm giving you 5 minutes. Write this code on your own and try to implement. We are not done yet. We need to do the prediction. Okay, how to perform the prediction? As we saw in the first block diagram that we took, the first block diagram that I yesterday explained, once the training is done, once the accuracy is found out, you can actually, you know, give the training information to the model and train it. Once the training is done, you can predict the output. Implement it and let me know if there are any syntax errors. I didn't run the code, so you guys are going to tell me if there is any error that I made in the code itself. I'll give you the code. Aishwarya, you can see this here in the tools. Just click on reset spider to factory defaults. There is one direct option here, or you can change your preferences in the tools itself. I'm showing it on the screen. Go to tools and reset spider to factory defaults. That should be enough. Bhuvana is asking like number of splits is assigned as 10, whether it is constant. It is up to you. You can choose any number of splits that you want. Lawrence sir, it is train test split. Train underscore test underscore split. The line that you shared, line number 67. Before test underscore split, you need to put train underscore. This one. See, I highlighted the function name there. Those who are getting the syntax errors, I'll share the code. Okay, first write the code on your own, then I'll share. Okay. So once you execute it, you basically see an output with a list of values. Actually, that is expectation. You will find the mean value and also the standard deviation. Okay. I hope everyone is able to see the outputs. Any more errors? Let me know. first get the errors and try to fix them on your own. Then I will share the code with you. Okay. So I'm sending you this code on code share. I'll share that link with you. There are few parameters changed. That's it. Everything is the same. Compared to yesterday, there are few parameters got changed. So let me execute the code and see whether I am getting the output or not. Let me remove all the variables here. Clear the console. Yeah. Save the code. So see, this is the format in which we are printing. Percentages. Did you understand why we wrote percentages? Percentages means the name of this string. The name of the algorithm. Percentage f is the float point of the mean value. The second variable here, the mean value, and the percentage other percentage f in the brackets, that is the standard deviation. So if the mean is high, means it basically you need to multiply this with the percentage, each value with 100. Look at the percentages. So we have LR as 95.18, 97.6, 95.1. SVM got the highest mean value and lowest standard deviation. Standard deviation means how deviating the precision could be, or the prediction could be at the end. So standard deviation should be very low for an ideal algorithm. So if you see, the first place goes to SVM, next place goes to LDA. Means SVM is proved as the most efficient algorithm for this data. Okay. If your data changes, let us say instead of using iris, I'm using some other information. Okay. In that case, probably these values may change, because the efficiency of algorithms basically depend upon the kind of data that you take. Okay. So I'll give you a small exercise where actually you can do this exercise later. Just note down this exercise. By using the same method or the same technique, implement algorithmic evaluation of data. You can take any data, it is up to you. You take information of cars, just take some data which is similar to the iris data set that we used. Means you can work on any use case. Okay, take any use case, take similar information that we have. Of course, we are dealing with the text information here, so take text information here only. So implement algorithmic evaluation of the data in a CSV file. import the data from CSV and perform loop-based evaluation of 6 scikit-learn algorithms. Okay, this is the exercise. You can try out whenever you're free. You can just try this out. Just the way you import the information will change. That's it, and the data will change. Then you need to identify, because the CSV data you can change easily, right? You can just change the information here and there. So by changing the information, you can see whether the information or the accuracy score is changing or not, whether mean value is changing or not, standard deviation value is changing or not. So once that is done, what you will understand is the efficiency of any machine learning algorithm is dependent upon the data as well. So more insights the data is able to give, more efficient your program is. Okay, so that is what we need to understand. So once that evaluation is done, you will realize how the efficiencies change by data. So now that, okay, let's look at the final part quickly. So now that I have the information and everything, so I have the information that SVM is the efficient algorithm. So now is the final part, implementing the prediction. That is the whole purpose of any machine learning program, right? I hope you guys are following the indent that I am following. Okay, you need to have the indent properly. Okay, just make sure you're doing it. So I will take, for predicting this, I'll take a value called prediction model is equal to prediction model is SVC. This is the function that we need to use. This is the algorithm which is proven that this would give you more accuracy of the information. That is my prediction model. And then I need to do what? Once the model is there, I need to perform training. How do you perform training? And moreover, you do training with what? The training information, right? Where is your training information? Xtrain, ytrain. Xtrain, ytrain. This is where your training information is available. So I would write prediction model dot fit Xtrain, ytrain. So what is this dot fit function do is, this will perform the complete training of the algorithm. And this is initializing function. So here you need to initialize the function like this. And finally, you need to do the prediction. So predicted flower. So finally you need to predict the flower. So we'll write prediction model dot predict Dot predict is the function using which you can actually predict this, predict which flower exactly it is. Okay. And to this prediction, what do I need to pass here is, let's go back to the information that we have. So you need to take a multi-dimensional array. Inside that array, okay, let's do one thing. Let's take a look at the information that we have and see whether it is predicting correctly or not. And okay, where is this link? Open the link that we have. Open link, the link of the data, the CSV file. This is the data. So well, let us see multiple values here. So 5, 5.4, 3.9, 1.7, and 0.4. I give these values and print the predicted flower. So what should be the result I should get? It should be Iris setosa, right? I'm giving the same value, so obviously it should give me Iris setosa only. Let me execute. Cleared the console and then ran the program. So can you see this output? See, after SVM it is printing Iris setosa. Okay. If you take any value, now let me take like the sepal length is, I'm taking random values here. I'm doing the actual prediction now. I'm taking every rounding of the values, like, and take this value as 7. Let's predict again. Okay. I'm actually getting the output as Iris setosa only. That is closer. Let me increase the size of this to 7. I'm increasing the values now. 8. I'm just randomly taking them. 4 and 8. Highest values. Run it again. It is printing multiple warnings. You can ignore that. See, it is predicting it as Iris virginica. Okay. And here it is not just an array. You need to pass a multi-dimensional array here with only one row. Okay. Do these predictions now. Okay, check for multiple predictions, multiple values. Do it for multiple different values. Okay. I'm giving you the complete code of this program. Check the code link. I just did prediction for a couple of times. You do it based on the values that you have. To get the URL, you know where the URL is, right? Just it is in the code. Take the URL value, take the link, paste it, take few values which are near to two things, like two different species. Okay, just confuse the algorithm and see how accurate your predictions would be. And obviously, 100% accuracy is kind of very tough with the machine learning problems. So no system is ideal. Okay, let's take a break for 5 minutes and come back. We will. I'll show you how to. We'll go to a new use case on NLP, natural language processing. Okay, one of the important technique. We are going to build a Python chatbot. It is a very huge project. I'll try to simplify it in a when it in terms of the execution.
Sir, the code you shared is old code, sir.
Uh, just a second. No, I refreshed it again.
Okay, okay.
Yeah, check it again. Okay. Let's break for 5 minutes and come back. Come back at
Okay, okay. Okay,
12:15. Okay.
okay.
We'll discuss more.
Students, you have to join again after 5 minutes.
Okay, everyone. Let us go to a new use case, a use case of NLP, natural language processing. Natural language processing is pretty simple to implement and pretty simple to understand also. It is analyzing the text information and building. See, even these days we are getting emails. Even in Gmail, we have NLP, which will analyze the mail that we got, and it takes a appropriate. It gives us an appropriate response. Same thing with chatbots, and there are various huge applications of uh, NLP are there across. So I'll teach you one of the best example that I personally came across. So let me share my screen. Open a new file on your Spider. Create a new Python file. This code is actually very huge, so I will make it simple for you. Just a second. Okay, make a new file. So the project that we are going to work on is, so this is the second project. So Python chatbot using PKinter, NLP, and lemmatizers. So a complete Python chatbot application. The use case that we are going to implement is hospital management chatbot. You can actually extend this to, you can also extend this to any other industry, whatever the industry that you want to do. So you can tap on multiple industries here, because chatbots are the, like, you can use it on online delivery stores or your own company or any CRM tool or BPM tool. It's up to you. So in this use case, we are going to work on a hospital management chatbot. Okay. So first of all, let us try to understand. See, the technique is the same here. Nothing changes. Like the same, the one that we used. So here the thing is, the basic building block would be the same. The steps that we are going to do is, first, data collection, or collect data, reprocess the data. Okay. Here the thing is, this example is little different from the previous one. Previous one we did evaluation. So here I am not showing you the evaluation part, because actually you can do evaluation for this also, but I'm straight away using one algorithm here. Okay, I'm not going to touch upon any evaluation process. So pre-process the data. As I told you, pre-processing is nothing but making the data more structured, uh, the making the information even more structured. So once you pre-process, customize the training algorithm, generate a model or make a model. See, the thing here is, once the model is made, Chatbot means what? If you are using a chatbot means what? You cannot do the prediction. Actually, you can do it using IPython also. See, in the console, you can say hi and it will respond. But here, what I'm instead of doing that in the console like a small project, I'm doing it as an end-to-end project. So what I'll show you is build GUI using Python for chatbot. Link the GUI. This linking, most of you may not be aware of previously. So what we are going to do is, once the model is generated, once you're ready to do the prediction, we take the model, okay, and we link that to a user interface screen. So we develop some screens. To that screen I will link up this model and do the prediction. And here prediction is nothing but the answer that this chatbot give you, right? That itself is the prediction, right? So let's do that. Link the GUI with the model, perform prediction. These are the steps that we are going to implement now. Okay. Just a minute. Let me connect to my Wi-Fi. Give me a minute. I'm switching my connection. Create a new file. Okay. Meanwhile, you guys do these steps. Create a new file and name that file as chattraining.py. Chattraining.py. Okay. I think I'm audible. Okay. Let me share the screen. So we are going to do a lot of word processing here in this entire code. Let us do step by step. First, collect the information. So first collecting the data. So basically to build a chatbot, you need to import. So step number one, import the chat dataset. How will the dataset look like? And we are going to use the format of data. Previously, we used the format as CSV format, right? Here we are going to use the format as JSON. So what is JSON? Anyone worked on JSON before? What is JSON called? What does it stand for? And can anyone explain the why we use JSON? What is the need of using JSON? I'll give you the data set. It is a very huge data set. Okay. I'll give you to download it. I'm sending you one link. I'm sending you one link. Open the link and download all the files that are in there. Actually, that is the complete project. I will show you how to build it. Actually, I cannot send you the JSON separately. That's why I sent it here. Just download that. You will download a zip file, unzip it, and keep it separately. Keep it somewhere. Yeah, did you download? So once you download, open that folder. I'll show you that folder, how it will look like. So this is that folder. Okay. If you see, actually this is after after you build the complete project. I will show you how to do it. Okay. So now open this one. There is something called intents. There is one file called intents. Open that. You need to unzip the folder to open it. So just make sure you unzip it. Don't do without unzipping. You may not get that option to open the code. Where is this file? So this is that one, Python project code, chatbot codes. Keep it in a new folder. I'm putting it on my desktop. chatbot application, chatbot application main. Make two folders, chatbot application main and also chatbot build. Chatbot application main, chatbot build. In chatbot application main, put your folder that you downloaded and unzip it. Actually, I gave you this code for reference, okay? Because few files we are going to use from here. And one more thing, so I'm repeating this, listen carefully. Make two folders, chatbot application main and chatbot build. In chatbot application main, put the downloaded zip folder and unzip it. Once you unzip it, you will see something called a file called intents. Copy this, copy that intents and paste it in chatbot build, because this is our data set actually, and this data set is in JSON format. For those who don't know what JSON format is, I'll show you how it looks like. I hope you guys are following. Open this file with any code editor. I'm opening with Notepad++. You can open that with any code editor that you have. So it will open this entire file. It may take some time. The file is huge. So this is how our data set looks like. If you see, this whole data set will consist of conversations, and it is divided in such a way that it is divided into multiple parts actually. Intents are nothing but the kind of conversations, and here there is a conversation called greeting. All the messages that you get in terms of greeting, hi, how are you, is there anyone, and all, they will be here. Those are patterns and these are responses. Okay. So, and you have various different data here. Actually, you can take this data in CSV also, right? Normally, whenever data is generated, when you download the data from your database, right? So where does normal data come from? Your chatbots that you see, your Google Assistant or any chatbot that you use, they take the conversations which are already done before manually. They will understand those conversations, use those as training information, and that data can be downloaded as a CSV file or a JSON file, however we want. Mostly in JSON file, mostly in the JSON format. Okay, so these are all the values that are here, and now we need to take this JSON file now. Where is the JSON file now? It is in the chatbot build. Okay, this is where we are going to build our project. Now let us implement the programming. Go to the spider code. Okay, new Python file. Create a new Python file, or I think we already created one. Yeah, is already there. I will save this file later. So first write the code. So we are going to use multiple algorithms here. First, let us do the initial setup. From the programming perspective, import all the necessary modules. First, import NLTK. NLTK is for word processing. It is for natural language processing. And first import that, and from NLTK dot stem import something called WordNet lemmatizer. I'll discuss about lemmatization when we implement this. Lemmatization is one of the important process. Meanwhile, you can also see what lemmatization is. Lemmatization is a normal process which is related to languages. It is not something related to artificial intelligence. Lemmatization is already, just look at the literal meaning of lemmatization. What does that mean exactly? So once I import that, I'm creating one lemmatizer variable, and I will use this function called WordNet lemmatizer. In the lunch break, you guys go through what lemmatization process is. Import JSON. You know one thing, in Python, JSON is not supported. You cannot modify JSON directly. You always need to convert your JSON into dictionary and then work on it. I'll show you those conversions. The reason why I'm importing JSON is because in order to convert a JSON format file or the JSON formatted information into a dictionary, you need to have this JSON module. Okay, and import pickle. Pickling is a process which is called, pickling is nothing but it just converts your data into serialized information. Okay, it just does serialization. So that is the purpose of pickling. And we are going to use numpy as an numpy, as just import it as np. And this is actually an example of deep learning problem. Okay, we are going to use the sequential deep learning model from Keras. Okay, you may need to import Keras later, so you need to install it actually. So we'll do that, and also import random. So these are all the multiple modules that we are going to use. Um, Various different libraries and modules that we are going to use for the implementation. Okay, import everything. Once you import it, just run it and see if you're getting any error. Let me know if you're getting error. I'm actually suspecting one error that you will get. So check that once. You may see a problem or you may find an error after writing this as Module KRS is not found. Let me know if you are seeing that error or not. So if you're facing the KRS error, that's not a problem. I'll show you how to install KRS. If you remember yesterday, I told you something um, how we are going to install a new library onto Anaconda. This is a very important procedure. See here. Go to Anaconda Navigate. Just go to Start. Go to Start. Open Anaconda prompt. Open it, and it will open a black command prompt screen for you. Okay. You may not see all these, but you need to install Keras, which is a deep learning module. So everyone will be able to see this. In your Anaconda prompt, you will see something like base and this pointer here. Open this and run a command that I'll give you. We need to install Keras in our environment and make our environment ready. Actually, in my environment, Keras is already there. But if you want to check, you can actually go and check. Go to your Anaconda Navigator. I have shown you where to check. Remember, where we can check the modules whether they are available or not. Go to environments, and here you can search for Keras. See, Keras is already available for me, but you may not be able to find it. Okay, that is the reason why we need to install it from the Anaconda prompt. There is one command I am showing you here. See carefully. This is the command. you need to run from the Anaconda terminal. This is how you install any module in Anaconda. Okay, take that command, put it here, and hit enter. I'm not doing that process, so I will be. I'm not going to do that process because it may take more time. Okay, just make sure it is getting installed. It may take a lot of time actually to install Keras. Once you start downloading it, uh, okay, let me show you how which kind of commands you may get. Okay, you will see something called solving environment, and don't terminate this process or don't close this window. It may take a lot of time to install it. Just leave it aside. Okay, just put it aside and we can continue writing the code. Open Spider, and all the imports are done. Now what I'm going to do is, see, I need to read the data set, and the data set is in a JSON format. Okay, so I'm going to create 3 different arrays: words, classes, and documents. We will build we will build and give values to all these. Don't worry, I'll show you. And I'm going to make a list, a small list called ignore underscore words is equal to, I need to ignore special characters, question mark, and exclamation is to Now, what is the data file? Data underscore file is one more variable, and that would be open. Open is the function you can default Python function. What am I opening here? The file of, see, the file that you saved here, chatbot build, which is nothing but the intents. There, my entire conversation data is there. Okay, so this is the data. Okay, I need to import this data. Open intents dot json dot read. Okay, intents dot json dot read. All right. So what we need to do here is if you print data underscore file, the kind of information, and one more thing, save this file, click on save as, save it in the chatbot build where intents is, and name this as chat underscore train dot py. Chat underscore train dot py. All right. Print this data file and see the format that is getting printed. Oh, I think the code is gone, I guess. Yeah. See, this is importing all the values. If you observe, you will see the output something like this with the intents. Okay. But the problem here is this is in the JSON format. You need to convert the JSON. JSON means JavaScript object notation. You need to take this JSON and convert that into a Python dictionary, because JSON is not supported in Python, so you cannot read any values. So I'll show you how you can convert it. It's pretty simple. Just give me a second. I think. Okay, I hope everyone is seeing this output. I'm sending this code. Just for now, import everything and keep ready. Okay. In the afternoon session, we will see how to take a JSON information and obtain the, because here the data processing is totally different. That is why I chose this kind of use case where the data processing that we did, the data pre-processing or the data analysis that we did previously is totally different. Okay. So let's see. Let me share this code. The code, I sent it on the chat. Get the code. Okay, execute that, and you need to take here. Okay, please execute the code. We will meet again at 2 o'clock after lunch, and we will continue with the data pre-processing and training as well. Okay, I'll see you at 2 o'clock.
Okay.
Thank you so much, everyone.
See you
Have a good
after 2 o'clock. Thank you, sir.